So let's start our session. So this station is having a robot named RV4FL. So this RV4FL is a six-axis robot, six-axis industrial articulated robot. We can use this robot to move our workpiece from one location to another. So the main job of this robot is, for example, pick and place. Then assembly, machine loading, etc. Or the specialities of the robot. What are the specialities of this robot? So I have mentioned the how many axes? Six, right? Six. That means six movements, right? Then accuracy, plus or minus 0.02 mm. This is the accuracy, plus or minus 0.2 mm. Plus or minus 0.2 mm. And speed. So the maximum speed is 9,900 millimeter per second. And maximum reach 48 mm, 648.7 mm. So these are the specifications. There is an end position and overload monitoring program integrated. This is another specialty. End position, end position program and overload monitoring. So this robot is having 32 inputs. So input means to the PLC, right? 32 inputs and 32 output means from the PLC. So this robot is having 32 input. Input means to the PLC and output means from the PLC. So total 32 input and 32 output. And next is the drive unit. I want to see a 750D or 750D. This is the drive unit. So drive unit means this is the controller. This is the controller to control this robot. And this controller is having different buttons, right? Emergency stop. This is a red color button. If you press this emergency button, the robot will stop immediately. Down button to change the menu. Go down. CHNG button means change. CHNG means change button to change the menu or change the setting. Then display button. Okay, it will shows the status of the controller, and we have a key switch. Okay, so by changing the key positions, we can select the mode from either automatic or manual mode. We have two modes, right? So by changing the position of the key switch, we can select the mode, either manual or automatic mode. Then USB cover, that is USB port battery access. Then a plug for teach pendant. What is teach pendant? I will explain in the next page. Servo on means we can turn on the power of motor. Servo off to power off the motor. Start means to start the program. Then we have similar to the down button, we have up button, right? So up button means we can go up in the menu. Then we have a main switch. This is to turn on or off the controller. Then we have end button to end the operation. Then have a reset and stop. This is front panel of the drive unit. Then coming to the back side of the controller. On the backside of the drive unit, there are some more plugs and interfaces. So drive unit, front panel, and back panel. So front panel I have explained. Then next is the back panel is having CN1 and CN2. So CN1 and CN2 means this we can connect the cable to the robot from this controller, CN1 and CN2. That means robot communication cable from the controller to the robot. Then CN user 11, CN user 12, CN user 13, that means user interface. Then we have slope 1, slope 2 that represents input output. Okay. So slope number 7, this one. 6, slope number 6 and 7. This shows input output 0 to 15 and then 16 to 31. Then CN user 2, there is additional user connection. LAN, then number 9 is LAN connection, LAN and for internet. This is for internet communication. We can connect MES, PLC, programming PLC to this LAN connection. Then coming to the each panel. Okay. Please teach panel. So using this teach pendant, we can control the robot manually. We can control the robot manually using this teach pendant. Then another one is called jogging. Jogging means we can move the axis manually. Then we can teach different position. Then we can edit our program. We can edit our program using this teach pendant. And if there is an error, we can reset the error. So these are the different use of the teach pendant. Then another very important point is that we have 3 different modes. We have three different modes. One is auto mode, right? Another one is that we can use either PLC or we can use another external controller. Communication with other controller or auto for standalone mode. Then position teach for teach mode. Okay, so next is our standalone mode. Standalone mode. So in order to operate the robot, what are the connections we need? What are the connections required? Okay, first of all, we need the robot, right? Then connect this robot to the controller. I have already mentioned we have two cables, right? CN1 and CN2, right? CN1 cable and a CN2 cable. So we can connect the robot to the controller using this. Then we need a drive unit. We need a drive unit. This drive unit is connected to the controller. So if we connect these three, robot will work like a standalone robot. So this is our robot, right? And this cable is what is called a CN1 cable connected to the controller. And this is what is called a CR750D drive unit, CR750D. Then coming to the programming setup. Okay, so during the program, so this is our teach pendant, right? And this red cable is connected to the controller. So we have our drive unit. So this teach pendant is connected to this drive unit. Then this is our PC, and this PC is what is called a programming PC. And this programming PC is connected to the controller using the Ethernet cable. So one is TB. TB means teach pendant or teach box. Then this cable, the red cable is the cable from teach pendant to the drive unit, and this is our programming PC, and this is our drive unit CR750D, and this is the cable to the Ethernet interface. This is the cable to the Ethernet interface. Okay, so here we can see this is input, right? This is showing the input. So input means I have already mentioned. This is, let me check. Yeah, so this is the input, right? Servo on, servo off, error reset, reserve, numeric value input, etc. So for example, let's say this one. Again, this is input, right? So WP clamped, right? What is the meaning? WP clamped means workpiece clamped. Workpiece available, avail means workpiece is available. Then workpiece orientation, okay. The orientation of workpiece is correct. Workpiece hole is okay. Hole is properly detecting. Then fuse mag 1 available. That means magazine 1 is having fuse available. Fuse available, right? Then fuse mag 2. That means magazine 2 is having fuse, right? Similarly, fuse magazine 3 available. Then vacuum gripper available. Vacuum gripper present, right? So vacuum gripper present. Then this is a workpiece gripper connected. Then gripper open, right? So gripper is opened like that. So this is showing the input. Again, this is showing the input, right? Then this is the output, right? So for example, stop. Okay, so, servo on. Okay, so PLC is saying to the system that turn on the servo. So this is output. Output means from PLC to the robot or from PLC to the system. That is what is called output. See, for example, very simple example, SRV on. What is the meaning? Variable name SRV on. SRV on means servo on. and the corresponding PLC address will be 100.4. So like that, servo off means servo on disabled. The PLC address will be 100.5. Servo off. Error reset. PRG select. A PRG SEL, that means program selection. OVRD SEL, speed override. PRG out, program output request. ORD out, speed value request. Again, this is also showing the output, right? So output means for example, workpiece mount lock, start camera, like that. Servo on, servo off, etc. Okay, so next is the parameter. So when we are configuring the drive unit first time, we need to enter this parameter. So this is for configuring the drive unit first time. So give the same parameter. Okay, such as tool offset, then So tool offset means this will tell you the controller about the exact position XYZ offset. Then communication parameter. So communication means between PLC robot, right? We have PLC. So communication means communication between PLC and the robot, right? So for example, stop 2000. Okay, if PLC is sending the stop signal, then robot will stop the program like that. Start. For example, start 2001, 2001, right? So if PLC send the start command, then the robot will run the program. Similarly, servo on, right? Servo on means servo on 2004. Then servo off 2005. Then error reset 2006, error clear. Then PRGSEL. PRGSEL means program selection. Then IO data. IO data means input IO data. That means sending numerical data to the robot. Then we have Ethernet camera, right? We are configuring the IP address of the camera. For example, 192.168.0.2, 192.168.0.3. So the camera will send image to the robot. Then we have slot parameters. These are background programs. For example, SLT1, robot main cycle, SLT2, home position monitoring, SLT3, vacuum energy saving, SLT4, PCB tray control, SLT5, pallet monitoring. Then coming to the main task for programs. The following programs have to be loaded into the drive unit and must be available there. So these are the programs we need to load into the robot controller. This will be like the library. This will be available in the controller. This will be like the library of the robot. So we have a main program, MB5. That means program to mount, say for example, no fuse. Okay, MB5 left fuse, MB5 right fuse. Then MB5 program to mount both fuse. 999 program to reset the global variable values. Then subprograms, beeper close. Beeper will close, right? So for example, GRP close. This is a subprogram to close the gripper. Then GRP open. This is a subprogram to open the gripper. Similarly, GR lock. That means a subprogram to lock the gripper to the robot flange. Then gripper release, subprogram to release the gripper from the robot flange. Grip vac on, subprogram to turn on the vacuum of the vacuum gripper. Grip vac off to turn off the vacuum off. Then initialize, right? This is a program to initialize the robot cell. Then monitor home. Robot will check whether the robot is in home position or not. Then monitor PALWS. Robot will check whether the robot is in safe zone or not. If robot TCP inside the bypass zone. Then mount PCB, subprogram to mount the PCB. That means if you run this program, it will place the PCB. Then mount top fuse. So it will place the top fuse, then mount bottom fuse. So program to mount the bottom fuse. And pick PCB. So subprogram to pick the PCB from the PCB palette. Then pick fuse, right? It will take fuse from the fuse magazine. Pick tool. It will take new tool from the tool changer. Pick from vision. Pick from vision means whatever image from the camera, the robot will pick from that place. Pick from vision. So program to pick the upper part of the vision field. Similarly, we have a pick to vision. This is a program to place the upper part of the vision field. Then sensor check. This is a program. This is a program to check all the required sensors for the main program. That means before starting the program, this program will check whether all the sensors are properly working or not. Then coming to the return message. Okay, return message means error. Okay, return message means error codes. Code 1. What is code number 1? Robot gripper closed. Number 11. Unknown tool type gripped. Then number 21. Undefined stopper number. Stopper number is invalid. 22. Unknown program number. That means program is unknown. 23. No workpiece on the pallet stopper. 31. Camera found no workpiece. 41. Workpiece assembly position occupied. 42. No workpiece placed at the assembly position. 43. Workpiece upside down oriented. 44. The orientation of the workpiece is not correct. 45. Workpiece not clamped at assembly position. And 52. Unknown PCB pallet number. 53. No PCB found at the ordered pallet number. 63. All fuse magazines empty. So for further information to the robot, see Mitsubishi robot manual. Next is robot positions. Okay, so PINIT home. That means this is the robot safe home position. Then carrier stop 1. Workpiece pick from stopper. This one. This is number 2. Carrier stop. Carrier stop 1. So from this, it will pick the workpiece. Then this third one, GRP storage VSE. This is vacuum tool storage. Then GRP storage WP number 4. Mechanical gripper storage. GRP storage fuse. Number 5, fuse gripper storage. This is PCB pallet 1, front left PCB. PCB pallet 12, front right PCB. Then PCB pallet 9, back left PCB. PCB pallet 12, back right PCB. So these are the coordinates used in robot program. And fuse assembly positions, page number 171. Yes. This is fuse magazine 1, then fuse magazine 2, right? This is fuse magazine 3, right? 1, and then fuse magazine 2, then fuse magazine 1. Number 4, assemble fuse 1. Number 5, assemble fuse 2. Assemble workpiece. Then number 7, mission. Next is our two quadrant controller. This is conveyor motor driver actually. Uh, Control for DC motors. This will control DC motors, anti-clockwise and clockwise rotation. So anti-clockwise and clockwise rotation. Then switch over from high speed to the speed adjusted, slow speed. Then import for limit switch for stop, dynamic braking, over temperature protection, short circuit proof and temperature protector. Then limitation for starting circuit. This is used in conveyor belt, DC motor, solenoid valve. Then coming to our technical data, this is very important. You see the power supply is 24 voltage, 24 voltage DC power supply, and the motor current will be 3 ampere, 3 to 5 ampere. This is the current. So 24 voltage DC and 3 to 5 ampere current. And the temperature range is from -20 to 40 degrees Celsius. And short circuit protection, temperature protection, and what is the total weight? Approximately 100, right? The weight of this one. ZS 430. So this is the connection diagram actually, right? So from the PLC, so we have PLC, right? So from the PLC output is connected to this controller, right? So from the PLC output, okay, move the conveyor in clockwise in right side, right? That means clockwise rotation. So we will get an output from the PLC to this motor controller and then DC motor. So the PLC command will be either clockwise rotation. Clockwise rotation means motor will move forward, right? So counterclockwise means motor will reverse. Then slow speed, here you can see. Okay, so this is A1 clockwise, and then A2 for counterclockwise, and then A3, this A3 for slow, and this A4 for stop. This is for manual counterclockwise. This 0 voltage represents ground. 0 voltage means ground. This is again manual clockwise. This one, this black button, and this one. This is the speed controller. This is 24 voltage, and this represents 0 represent VCC means 24 voltage, and this means ground. And next is the changeover gripper system. This is actually automatic tool changer system. So the robot is having 3 tools actually. Vacuum gripper, workpiece gripper, fuse gripper. Fuse gripper means it will pick fuse only. Then workpiece gripper, it will pick the workpiece. Vacuum gripper will pick the board. So based on the program, tool will select appropriately. Okay. For example, if the program is to assemble fuse, then it will change the vacuum gripper to fuse gripper, and then it will pick fuse, and then it will assemble. So the specialty will be pneumatic locking, automatic mechanical lock, electrical connection, proper alignment, and the operating pressure will be 6 bar. Whole data on 6 bar. Next is electrical port on the LED floodlight. So this is the connector to give electrical signal and pneumatic air to the tool changer. So what is this LED floodlight? So LED floodlight means this is the light of the camera vision system. So we have a camera vision system, right? So that the robot can see the workpiece properly. And this LED floodlight will give to reduce the shadow and also make sure that the camera detection is precise and accurate. And the LED power will be 23.8 watt. The supply will be 12 V volt, right? The color temperature will be 6500 K daylight white. So brightness will be 3080 to 500 CD per meter square. Okay, coming to the main brain of the entire system, PLC. PLC is, this is our brain actually. This is the brain of the complete system. So in this picture, we can see Siemens ET200 SP slash CPU 1512 SP F1 PN. So this is the brain to control the entire assembly station. So what is the duty of this PLC? So this PLC will check whether the whether the whether the system will get all the necessary informations from the sensors or not. For example, whether the work is reached or not, whether the conveyor is running or not, whether the robot is in home position or not, whether the camera identified that object, what about the RFID status, what about the emergency stop, everything, all the informations this brain will check. Okay, once this brain will check all the inputs, it will give output, right? So based on the input, this will give, say, start the conveyor or stop the conveyor or move the robot, vacuum on, vacuum off, gripper open, gripper close, camera trigger, RFID read, etc. So this this means fail safe. Fail safe means this can handle safety functions also. That means if you press emergency stop, PLC will stop robot, conveyor, vacuum, etc. So this is the brain behind the entire system. This is from Siemens company, right? So next is the touch panel, Siemens touch panel HMI. So this is Siemens TP700 Comfort. That is the name of this touch panel. Okay, what is the use of this touch panel? Okay, user, this is actually a touch screen. So user can touch the different options on the screen so that he can start, stop, reset, select different modes such as automatic mode or manual mode. And also the operator will be able to see what are the alarms, what is the current status of the robot, what is the current status of conveyor belt, what is the current status of sensor. All the informations uh, the operator can see through this touch panel. This is like a mobile phone screen. And coming to the specifications, 24 voltage DC, okay, like similar to the PLC. And the current will be current consumption will be 0.5 ampere. And the power consumption will be 12 watt. That means no extra electricity is required. And the processor is x86. This is the processor. This processor will operate the HMI software. Memory is flash memory. It will store the program. RAM, yes, running data. So user memory 12 MB. So during the maintenance time, all the alarm reset, auto start, manual jogging, sensor monitoring, everything we can control using this HMI screen. Then this is what is called a Scalens Ethernet switch. So this is a Scalens X208 Ethernet switch. So this is actually an industrial Ethernet switch. Okay, so using this, we have multiple different devices, right? How these devices are communicating, right? So to communicate different devices, this Ethernet industrial switch is using. Right? We have PLC, right? So we have PLC, we have HMI, we have robot controller, we have cameras, RFID, and etc. So multiple devices, how multiple devices will communicate through this Scalance Ethernet switch. It is having RJ45 jacks. And 8 Ethernet ports. Every port we can connect one device. And remember, for example, we have PLC, right? So we have PLC, right? So I'm not able to write. So we have PLC, right? Okay. So from the PLC, it is connected to this switch. Then from the switch, connected to the robot, camera, HMI, RFID, MES, laptop. And everything will be under same network. So communication will be possible between multiple devices. So in this switch having RJ45 pin, right? So different pins such as pin, right? So pin 1, okay, then pin 1 transmit plus pin 2 receive, pin 3, 3, 4, 5, 6, etc. Another one of the feature is called auto negotiation. So auto negotiation switch will find itself speed, what is the duplex mode. For example, whether the connection is 100 Mbps or not, or 1 Gbps or not. So based on that, it will uh, allow the communication. Then MDI or MDIX auto crossover function. See, in our traditional days, uh, we used a straight cable, right, or a cross cable, right? Okay, but using this Scalance switch, we can use only straight cable. Straight through cables can be used throughout the crossover Ethernet cables are unnecessary. Then autopolarity. If autopolarity means if we connect the cable Ethernet wire wrongly, switch will correct it properly. If the pair of receiving cables are incorrectly connected, the polarity is reversed automatically. So one of the main important point mentioned in this manual is that in the switch we have two ports, right? So do not make a loop by putting cable into these two ports. Okay, it will create network crash. Such a loop can lead to network overload and network failures. Then coming to the main important topic, what is called RFID. RFID Ethernet module. So this is what is called TURC RFID Ethernet module. So what is the main job of this one? So the main job is to connect RFID to the RFID reader to the PLC. See, PLC will not read RFID directly. Okay, so RFID is a module. Okay, so RFID is a module, right? So tag data. So tag data is sending into the PLC. So this tag is having a data, right? So this tag is having a data, right? So that tag data is sending to the PLC. Then input output data mapping. So for example, input output. Okay. Okay. For example, input means status data. Okay. Whether tag identified or not. Okay, whether the read is completed or not. Is any error will be there. Okay, output PLC will send read command, write command, reset, select channel, etc. Then coming to the wiring diagram. Okay, how this RFID is connected. Okay, how RFID is connected. So we have the RFID head. Okay, and this RFID head is connected to the Turk module, right? And we have Ethernet cable and SCALANCE switch, and the SCALANCE switch we have discussed, right? Okay, and then connected to the PLC. Finally connected to the PLC. So this this is what is called a RFID read write head. Okay, once the workpiece reaches here, it will read the RFID tag. Then coming to the specifications. Yeah, this is what is called RFID read write head. Okay, so this will be available in the conveyor stopper. Once workpiece will be available, it will read the RFID tag, and the specifications will be operating voltage 10 to 30, 30 volt DC voltage, and the operating current will be 80 milliampere, and the frequency will be 13.56 megahertz. Communication will be inductive coupling. Okay, so inductive data transfer means inductive coupling. That means there is no inductive coupling means data is transferring without any touch. Okay, there is no need to touch the tag. Using the magnetic field, the data is transferring using the magnetic field. And the read distance will be maximum 30 mm, right? So maximum 30 mm means tag should be very near to the sensor. Then only it will detect. So in the RFID tag, having the part number, the product ID, process status, production data, everything we can store. So next is called MUR, microelectronic circuit protection. This is actually an electronic fuse module. So the job of this is to protect 24 voltage power supply. If some short circuit will be happening in a circuit, it will turn off that circuit only. Okay, other circuit will work safely. Okay, so it will protect the, this is show electronic circuit protection, right? So it will, if some short circuit will be happening, this will turn off only that circuit only. Other circuit will work normally. So because of that, it will save the PLC, right? Similarly, sensor, camera, robot controller, and also this will reduce the downtime. And coming to the specifications, the operating voltage will be 24 volt DC, and the selectable current will be 1 ampere, 2 ampere, 4 ampere, 6 ampere. So based on the requirement, we can set. Then alarm output. If some fault will be happening, to the PLC, it will send an alarm. Okay, so coming to this, this is the main power supply unit. So this will be converting AC voltage into DC voltage, 24 voltage DC. So the input will be 100 to 240 voltage AC. So the input is 100 to 240 voltage AC. So convert this AC to 24 voltage DC. So from this, so the output will be 24 voltage DC. So from this, PLC, sensors, FMI, WAN, everything will get run from this main power supply unit. So this is, yeah, the input voltage will be 100 to 240 voltage, right? And yeah, output will be 24 volt DC, right? So output will be 24 voltage DC, and the nominal output current will be 10 ampere. So this is the current to the sensors, valves, PLCs, etc. Then next is the Siemens US Sirius safety relay. So this is actually the relay that will provide machine safety. This is a safety relay, provide machine safety. It will check the emergency stop. It will check the uh, safety door. Okay, if some uh, accidents will happen, immediately it will stop the machine. Okay, without pressing reset button, it will not work. Then we have a multi-pin distributor, MPD. So this is what is called a sensor actuator connection box. Okay, so we have multiple sensors, right? So we need to connect all the sensor wires in one location. Okay, and from here, the connection will be given to the actuator. Okay, so this is what is called. So sensor actuator connection is what is here in this multi-pin distributor, multi-pin plug distributor. Okay, all the sensor wires will be connected here. Okay, from here, actuator connections will be given. And also this will send signals to the PLC and it will show status using the LED. Yeah, this is the multi-pin distributor, right? So 1 to 1415, 1 to 1415, right? Yeah. So 1 to 1415, 1 to 1415, right? So 1, 2, 3, 4, 5, 6, 7. Okay, coming to the syslink interface. So we have our PLC, right? And we have our station, right? So we have PLC and we have our station. So this is what is called an interface. So the interface between the PLC and the station. This is the input output. This is the input output interface between the PLC and the station. This is having 8 inputs, right? 0 to 7, right? And 8 outputs and 24 voltage supply. so that the wiring will be very much easy. So syslink pin 0 to 12, right? Okay. Coming to here, next one is conveyor motor. Okay, so we have conveyor belt, right? So to run the conveyor belt, we need a motor required, right? So this is the motor used to run the conveyor. Okay, so when the motor is running, the conveyor will be moving, right? So that pallet will be moving from one station to another. So again, PLC will be controlling this start or stop of this motor. So as per the instruction from the PLC, the motor will start, then the then conveyor will move, right? Yeah. Coming to the stopper unit, okay, so we have uh, we have pallet, we have carrier, we have carrier with pallet and workpiece is coming, right? Okay, so it will come here. So there is a stopper here, right? So based on the up or down movement, we can stop the movement of the carrier. Okay, by adjusting this stopper movement up or down, we can uh, we can either stop or move the uh, what you called carrier. So what are the parts involved in this? Okay, it is having this one. This one is RFID read write head. This is what is called RFID read write head. Okay, then we have pallet sensors, right? So these are the pallet sensors, and we have a pneumatic stopper cylinder. Then similarly, cylinder position sensor, right? Then flow control valve. So the conveyor is coming, right? So when the stopper cylinder is going moving up, okay, what will happen? Stopper will move up. So conveyor will, sorry, not conveyor, pallet will stop. Okay, once pallet will stop, this this will read. Okay, this is the read write cut right. So this will read the RFID tag. Okay, and communicated with the PLC. Okay, so based on that, this stopper will go down. Okay, then conveyor will move to the next station. So this is showing the pneumatic diagram. Okay, this is the pneumatic diagram of this. This is the pneumatic diagram of this stopper unit. So we need compressed air, right? So we need a 6 bar pressure compressed air is required to operate this. Then we have a filter and pressure regulator, right? So filter will filter the air and necessary pressure will be regulated. And through the pressure gauge, we can check the pressure. So we have a pressure gauge, right? So using that pressure gauge, we can check what will be the pressure. Then once once the system will get a command from the PLC, okay. Uh, Once the solenoid valve will get a message 24 voltage signal from the PLC, then solenoid valve will change. Okay. Once the solenoid valve uh, will change, cylinder will either enter or exit from the uh, cylinder. The air will be either enter or exit from the cylinder. Okay, so that pallet will stop or work move continuously. So if needed, up cylinder for next uh, pallet operation to position the next pallet operation, we can use up cylinder also. So the working will be very simple. So from the compressor, air is coming. We can check in the pressure gauge, we can check what is the current pressure. And through the filter and regulator, control the pressure. Solenoid valve will turn on. Then cylinder will enter into the valve. Then this station transportation, this is to move station from one location to another. Having a knob here, this is to adjust the height of the machine. Then we have a roller. This using this we can move station from one location to another. Then there is a lock nut. Okay, we can fix the machine in a particular location using this lock nut. So if you want to move a station from one location to another, release this lock nut. Then using the star knob, okay, reduce the height of the station. Then immediately the machine roller will touch on the floor. And after that, we can move the roller. You move the roller so that we can move the station from location A to location B. Then once the station reaches to the new station, we can fix it using this star knob by tightening the lock nut. So do not place your hand or leg below the bottom side of this station. So it will create so that your hand or feet will crushed or trapped into this area. Then operation panel working position. So this is our operation panel, right? Okay. So how we can open this operation panel? Press the bottom side, right? Then raise the panel slowly on the top direction. And there is a gas spring. It will stand properly like this. So, so this spring, this spring will hold this panel, this operation panel. Then how to close this? Press this spring centrally and slowly fold this panel to the downward direction and completely close it. So make sure that your spring is properly locked. Otherwise, what will happen? This panel will go down and it will damage. And also check your hand also. It is also important to ensure that no third person can fold the panel down. Make sure that the springs are vertical and the panel is secured against folding down. Failure to heed the information given can lead to injury. So sometimes your hand will be here, so it will create injuries. We have three types of error messages in the HMI screen. One is class 0, class 0. So class 0 means displayed in red color. This is very dangerous message. Okay, so what will happen? The program will immediately stop. Immediately automatic mode is terminated. We have to rectify the error first, and then after that reset it. Okay, then after that again start the station. So for example, if you press the emergency stop or if you open the safety door, you will get a message in red color. This is class 0 message. Then we have a class 1 message. Once the cycle is completed, it will stop. Again displayed in red. But the thing is that it will complete the current cycle. The program and the automatic mode are stopped at the end of the cycle. The current cycle will continue. Once the current cycle will finished, it will stop. Okay. After that, we have to rectify the error and restart the station. Then we have another error called in yellow color, that is called class 2. Yellow color means we have a warning only. Okay, so program will continue. Automatic mode will not stop. The program and the automatic mode are executed further. If the cause of the fault is fixed, the error is automatically acknowledged. Then coming to the some error messages. Let's see some error messages, robot error messages. For example, safety door open. Okay, so how to fix, for example, safety door open, right? So how to fix this error? So close the safety door and acknowledge the message on the control panel and robot control. Then, for example, another say see emergency stop is active. Right here the error is emergency stop is active. Check the emergency stop button on the robot and acknowledge the message. Then robot not in home position. Robot not in home position, move to home position. This is the error right now I am facing. Robot not in automatic. That means switch on to automatic at a drive unit. Then, for example, fuse magazines are empty. That means we have to fill up magazines. No PCB box available. That means no box, right? So we have to provide box. So like that, these are the message text of the robot assembly and how we can fix those errors. Then we have interactive error messages. Okay, if you will get an error on the HMI screen, you will get a pop-up message like this. Okay, so you have three options: repeat, ignore, and abort. So repeat means the same job will continue again. Ignore means the error will ignore. Okay, then abort. Abort means completely, it will completely stop. So we have three buttons, right? Repeat, ignore, and abort, right? That means repeat means the same order will run again. Ignore means MES will consider it as step complete. Abort means uh, order will treat it as an error and it will close it. We have one more button called reject order. Okay, it will reject order. Okay, if the next workpiece is coming, it will start again. Okay, then we have another error called 100. Order aborted with the errors. So the solution will be, okay, start again. And coming to the maintenance side, Festo is saying that the system is actually the components and systems from Festo Didactic are maintenance free, but regular intervals check optical sensors, fiber optics, reflectors, then proximity switch, the entire station, and also clean the station using either a soft lint-free cloth or brush. So do not use any aggressive or abrasive cleaners. Okay, so and also do not use uh, any alcoholic cleaning agents. It will damage the protective covers. So there is a risk of embrittlement. So next, how we can start the station, right? First of all, give the established main supply 400 voltage AC. So main power supply 400 volt. And then after that, uh, turn on the compressor because we need 6 bar compressed air. And this is our control panel, right? This is our main switch. And then we have pressure gauge or manometer. Then we have the touch panel, HMI touch panel. And then we have a network port, right? So a network port, and then emergency stop, then reset button, this one. This is the reset button. Operation mode selector. So this is the assembly sequence, right? So this will start. It will receive the start command, all right, and it will check whether fuse, robot, everything is ready or not. And after that, it will start the main program, send the program parameters, check whether the program number is correct or not. The system will wait till the robot is ready. This is the sequence description of the robot assembly cell. So it will receive the start command, right? Check everything is ready, fuse, robot, everything is ready or not. And after that, it will start the main program and send the parameters. Okay, send the validity of the program number and stopper number. So wait till program run. So these are the steps involved in automatic mode. Then we have a bypass mode. Okay, so this is the stopper and bypass, right? This is the stopper without RFID. Number two. Number three, this is the branch. And this is the stopper bypass branch. If carrier is coming, sensor will detect it, right? So if bypass is free, then stopper will go down. Then after carrier is going, then stopper will go up. This is a stopper without RFID, and this is automatic stopper in bypass area. This is bypass bend off, and this is bypass spread. Okay, so let's see the main architecture of form of operation panel. Home, setup mode, parameters, system. So home will give you the station status. Setup mode is for manual operation, and parameters is for we can set different parameters, and system is for system configuration. And this user is for login or administration. Input output test. This is to check whether the input or output is correct or not. So this is to log in the station as an administrator. Okay. So we have three options: administrator, Festo, and PLC user. So using the required username and password, enter it. Okay, and once you enter, you will get the user settings. And test this for input output settings. If you log in like an administrator, you will get the advanced options. Coming to the operation mode, the station is having mainly three types of modes. One is reset mode. Station will go to the home position. Once we will turn on the machine, press the reset button. And if there is an error happened, again press the reset button. Before starting the automatic mode, press the reset button. If you press the reset button, then station will go to the home position. Then we have a mode called a setup mode. This is maintenance mode. In this mode, we can run the conveyor, check the sensors, operate the cylinders. We can test the robot. We can troubleshoot. Then finally, the automatic mode. Automatic mode is production mode. In this mode, all the operations will be handled by the PLC. Manual control is not possible in this automatic mode. And in the automatic mode, we have two options. One is default mode and MES mode. So default mode means every station will work individually, and the operation will be based on the PLC program. This is for small systems. But if the factory is a big factory, we have MES system, manufacturing execution system. It will control the entire station. The MES mode, where the system is checking whether the station is ready or not, or the station is busy, application is active or not, carrier order, RFID informations, current program timeout, status indicators. Green color. Green color means if the color is green, that means that function is active. Then this default mode. So we have MES mode, right, and we have default mode, right. So default mode means without MES. Here we can see the RFID status, sensor status, carrier information, and the station information. Reset. See operation mode reset. Once we turn on the machine, press the reset button, and conveyor will go to the home position. Robot to go to the home position, and all stopper will go to the home position. Everything will be reset. So once we have completed the reset, then only use the automatic or setup. Then coming to the setup mode. If we press the setup mode, maintenance mode will start. Okay, each and every device we can test separately. Troubleshooting is very easy. Okay, then coming to the application. So go to the setup mode, and in the left side, we have different options, right? So for example, application is showing. So this is showing the signals, robot signals. So X start means robot start, X stop, robot stop, X servo on means servo on, X servo off, X error reset, robot error clear, X RC ready, robot ready. X battery error, battery low, X route robot up, X road 1 robot home position, X teach mode, X automatic mode. And on the right side we have connect, right? Then start program, retry, exit cycle. Then what is the program number? Then what will be the override speed, etc. Okay, let's see one by one. So this is number one, right? So what is number one? So number one means this one. This is the input. So this is the input, right? So input means the data given to the PLC input. That means the robot is giving input means robot is giving input to the PLC. That means robot is ready, right? For example, robot is ready. Servo on, right? Home position, error, etc. Okay, output. So output means PLC is giving some commands to the robot is what is called the output. Okay, for example, start, stop, servo on, servo off, reset error, etc. This is belt 1 to 3. So belt 1 to 3 means we can manually control the belt. So every belt is having left, right, drive, slow speed we can select, and the different sensors also. This 4 will be the we can set the speed of the robot here override. So here, yeah, here we have three belts 1, 2, and 3, right? So each and every belt we can select left, right. So left, right, then right, then slow speed. So here we can see the different sensors BG26, right? BG26, BG27, then BG52, right? And then BG53, right? So this sensors will be used to check whether what is reached or not. First of all, turn on the main power supply, then turn on the compressor. We need 6 bar pressure. Okay, press the reset, release the emergency switch, and press the reset button, and go to setup mode and check everything: sensors, conveys, robot, everything. Select either default mode or MES mode, and after that select the automatic mode, and then after that start the production. Okay, in the screen where you can see three belts, right? Belt 1, 2, and 3, right? If you push this belt left, belt will go to the left side. And if you press right, belt will go to the right side. Slow means reduced speed. Preset slow means we can set a speed, a slow speed, and that speed conveyor will move either right side or left side. So the same operation, whatever be the operation of belt 1, exactly the same operation to belt 2 and belt 3. We can control manually these three belts. So this is the graphical representation of the conveyor layer, right? Where we have sensors BG26, BG27, then BG52 and BG53. So these are photoelectric sensors. And we have stoppers ST1, ST2, and ST3, right? And this is band 1, band 2, and band 3. That means this represents the conveyor belt. This is band 1, band 2, and band 3. If the color is green, that represents that sensor is activated. So now BG7 is activated. Then this blue, this represents actuator. This is related to the actuator. Okay, and this green means sensor, related to the sensor. Okay, same way we have belt 1, 2, and 3, right? Okay, then coming to the stopper 1, right? So we have a stopper 1. So we have completed belt 1 to 3. The next is stopper 1. So here we can control the stopper manually. So we have two button, right? Sorry, we have this down button, right? If you press down button, stopper will go to the down. And here we have a sensor BG20, right? Okay, if you press this down button, okay, then this sensor will be activated. Then RFID TF80. Here we will get the information about the RFID tag. So in the MES mode, carrier ID, operation number, resource, operation data. In the default mode, it will shows the RFID status of it. So the function of this RFID is to initialize the RFID dataset, read the RFID, and after that write to the RFID and delete data. That means delete the input data. So again, this is a stopper 1. Okay. Then similar to stopper 1, we have another stopper number 2. Again, the same principle, but this will be controlling stopper number 2. Again, we have the sensor BG30, right? Yeah, this is BG30. Then we have carrier TF81. This is to show the details of that particular carrier. Okay, same way we have another stopper number 3. Again, the sensor number is BG42, right? Stopper number 3 finished. Then we have bypass, right? So this is to bypass gate manually. Okay. So we have actuator MB40, right, and sensor BG40. So open, if you press this open, it will open the bypass gate. Okay, actuator MB41 and sensor BG41. And BG35, this is the sensor to the bypass. Okay, so we have discussed about this one bypass, right? So we can either open or close the bypass, right? So the sensor associated with the bypass is BG35 and BG40, right? Here the actuator is MB40. So if I click this open, then bypass will open this gate and MB41 actuator will work. So BG1 sensor will say that, okay, gate is completely open. So the position sensor near to the bypass will be BG35. So during the maintenance check whether the open close is properly working or not, then check BG40, BG41, check. And then coming to the next one, so box belt. This is the manual control screen of the uh, clamping unit. Okay, so we have lift and then H1MB5 actuator, H1B5 BG5 sensor. Okay, if I press left, belt will go to the left side, right, belt will go to the right side. Reset slow means it will move in a slow speed. And we have box movement, box out, box in, right? Creep feed means very small speed. And we have the RFID data of the box. Uh, in the left side, initialization, read, write, delete data, right? So RFID status will be shown here, whether the tag is available or not, ready or not. And coming to the last one, that is our Apple camera. So this is to check the vision camera. Okay, if you press this camera display, it will show the latest image that has taken. So this one is leave web server exit. This 2 is to refresh the image. 3 means previous image. Then this function is not working. 4 means next image. And number 5 is the last captured image. And 6 represents the magnifying glass. 7 means zoom in. 8 means zoom out. Then we have our parameters, right? We can change the application settings using this parameter. We can either turn on or off the application. Once completed, you have to confirm in the operator HMI screen. Okay, now if we finish everything, then we can exit the operation mode setup. Press the cycle end button. Now you can see automatic mode is selected, right? If the automatic button color changes to blue, then that means automatic mode is activated. If you press that button, automatic mode will start. Conveyor, sensor, robot, everything will work based on the program. Then we have, then we have main operation mode, right? So this is the main menu where we can reset the system. Automatic cycle will start, or we can go to the setup mode, or we can press cycle end to stop the existing operation. We have two different modes, default mode or MES mode. MES mode means the software will control everything. Default mode means PLC program. The station will work based on the PLC program.